In this video, we'll be talking about the enhanced smart electrical connector that has been included with all the mechanical equipment families. This was in part due to development for this shared model coordination and utilizing as much common data between mechanical and electrical as we could, thus eliminating any duplicate information which can lead to errors. So what I'm going to show you is specifically optimized for a shared mechanical and electrical model, and it starts with mechanical just filling in your own information. So what we have in electrical loads is all the different types of motors that equipment might see, and we've started to determine all of their loads. So what electrical is after is full load amps, and what mechanical has to offer is quantity and size of motors in horsepower ratings. So what we've done is we've included the NEC table 430, which has rated full load amps for different types of motors based upon voltage and phase. So that table looks like this. I don't know if this has been discussed much elsewhere in the user manual, so maybe this is the first time you've seen it. But essentially, this is the table that's included in every mechanical equipment family that has a motor. I should say a fan or pump motor. This doesn't really apply to compressors. But what we have is, as soon as electrical chooses a voltage and phase for a piece of equipment, we're able to go into this table and use the mechanical data for what horsepower that motor size is directly from their schedules, and then we're able to return the full load amps. So now we're able to start calculating full load amps, MCA, MOCP, and ultimately apparent load before a selection is even completed. And electrical has the full ability to override any of the numbers, or they can choose to use the mechanical values to start. So the user manual does a good job of kind of explaining the order of information in regards to the calculated FLA and MCA. Maybe I'll pull that image up here. But essentially what's going on is mechanical enters motor quantity and power from their schedules, and then that information is used to go to this lookup table. So once electrical has chosen voltage and phase, then from the table we can return a motor full load amps. And now once we have all of these pieces of information for full load amps, we can start calculating the FLA and calculating the MCA. And so electrical can use that information or not. But what you'll see is we are able to get an apparent load very, very quick for electrical. So let's see how this works. So I have an energy recovery unit. So we just have essentially 3 motors and potentially some electric heat. So we've got a primary supply fan, an exhaust fan, which is our secondary motor, and then we have an auxiliary motor for like the little motor on the energy wheel. So what we can do is we can just start entering in properties, and these would be the properties found in mechanical equipment schedules. So as soon as we entered one motor, 1.5 horsepower, the NEC lookup value was 1.5 horsepower, and then a motor FLA was returned of 3 amps. And now this value can be used as the calculated FLA, which ultimately goes into FLA unless electrical overrides that. So we have this parameter here, motor power NEC lookup, in case a user enters an incorrect value that's not found in the table. And essentially we're rounding up to the next value. So if someone entered 1.55, for example, we'd be rounding up to the next rated motor size in the NEC table. All right, so let's say we have 2 supply fans at 1.5 horse, and we have 2 exhaust fans at 1 horsepower. So as you can see now, we have our calculated FLA, which is essentially adding up these multiplied by the quantities. And then the MCA takes into account the largest motor multiplier value, which I think is a type parameter. Let's take a look here. Yeah, so largest motor multiplier, that's what's being used to calculate the MCA. So just like that, entering in a couple horsepower values, we're able to get electrical all of their load data, and not to mention an apparent load at the connector. If we go up into constraints, you'll see that electrical has the full ability to override any of the values they want once a final selection is made, or maybe it's a packaged piece of equipment and there's rated load data to use. That would be another situation where you'd use these overrides. However, we can generate the information so much faster. So if we look at an ERV schedule, and we have, let's go to the sheet that has that. So one of the new workflows that we have in the MPP is the idea of a summary schedule. Essentially, these would be used for DD level efforts where you don't want this big schedule with a whole bunch of information not filled in. So as you can see, these are the values we just edited. So for a DD level effort, you go and start editing your motor powers, and just like that, we now have an apparent load that electrical can start designing off of. Now, say for example, we need to add, there's no longer a heating water plant on this project, and we need to use electric heat for preheat on the energy recovery unit. So we can turn on the heating element, which, as we discussed in the previous video, will change this coil description to electric preheat. We can give it a value. So let's say we have a 15 kW heater. So DD level effort, we just filled that in. However, let me go one step back. Here's our current calculated loads, calculated FLA, MCA, and all these values. As soon as we enter this, immediately we're able to get electrical a good estimate of load data that they can use for the time being or override if they need. And that is how mechanical will be able to provide electrical load data so much faster.